All right, so we've got two different spinners. And one is divided into 4 equal sections, right? So we can draw a picture of that if we need to. We can say this is spinner X. And what do we have? We've got a 1, a 2, a 3, and a 4. Now we got spinner Y divided into 3 equal sections. So we'll see if I can draw that here. And what do we've got? We've got red, we've got green, and we've got blue. All right, so we can use the correct colors for those. That is going to be spinner Y. So the possible outcomes for each spinner are shown in these tree diagrams, right? So spinner's got 4 possible outcomes. Spinner Y has got 3 possible outcomes. We've got 2 spinners. What is the probability that spinner X lands on 2? So if we've got a spinner right here, goes on 2, and then spinner Y lands on blue. All right, so what are these probabilities of these two things happening? Well, if we were to spin both at the same time, right, let's come up with some sample spaces. So I could possibly have from each of these, so I'm going to do an X, right, and a Y. What happens if my X lands on 1? Well, I could have a 1 and a red on Y, a 1 and a green on Y, and then a 1 and a blue on Y. And what we could do is we can simply repeat this. What happens if I land on a 2? Okay? Because that's really what I'm looking for. I can have a 2 red, a 2 blue, which this is the one I'm looking for, right? X on 2, Y on blue. And then I could have a 2 on green. So those are my only options there. But I've got the X's on 1s, I've got the X's on 2s, right? I could have an X on 3. I'm just going to repeat these, right? I can have a red, I can have a green. It doesn't really matter the order that you put these as long as you list all of them. And then the final one is I could have X on 4. And I can just repeat the red, the green, and the blue. All right, so this is my sample space, listing all of the possibilities here. Since I've got 2 different spinners, this is what we call a compound probability because there are 2 different things. It really just means it doesn't have to be 2, it can be 3, it could be 4. It just means more than one possibility that is going to be determining the outcome. So if I were to only spin once, that'd be a simple probability, or roll 1 die, that'd be a simple probability. All right, so what we have here is we've got a sample space, and I've got how many options? Well, let's count. 3, 6, 9, 12. I've got 12 options. Only one of them works, right? So that kind of lands itself on that 1/12. There are 12 different possible solutions, and only one of them works. So that would be 1/12. Now, there is a shortcut to this. If you have a compound probability, what you can do is you can take the probability of each of those single events, right? So I needed to land on a 2. What's the probability of that? 1/4. I needed to land on a blue. What's the probability of that? 1/3. When you have compound probabilities, you can actually multiply the probability of each of those simple probabilities. 1/4 times 1/3. What does that get you? Well, it can get you 1/12, which is our answer, B.